our journal entry, we're going to go to page 4 to do something called the mean value theorem. And all that is from our previous note where something special happens with the mean value theorem. That's where the average rate of change equals the instantaneous rate of change. What I want to do here is set up an interval. And instead of labeling this x like I did the other time, I'm going to label this a. And point here, I'll call this point b. And the deal is, if I were to draw a secant line through those 2 points, I would be able to figure out the slope of that line. And the slope of that line would be figured out using the AROC formula. Not quite the difference quotient. It's basically this. F of b, which is basically y sub 2, minus f of a, which is y sub 1, all over x sub 2, minus x sub 1. And that's the AROC formula. The deal is, there's some point on this interval of a to b, and we label that interval like this. Closed interval from a, including a, to b, including b. There's some point on that interval where the slope of this line of the average rate of change is going to match up somewhere, at least once, with the slope of the instantaneous rate of change. They're like parallel lines. And notice it's not at that point, it's right there. There's some spot, and we're going to call that point C. And they label it like this, where f prime, where the average rate of change equals the derivative, which we said is the instantaneous rate of change. So that's the note. The mean value theorem states that somewhere on this interval from a to b, if I connect 2 points, that the slope between those 2 points is going to equal the derivative somewhere between those 2 points. So from this technical jargon, we can say that the AROC equals the IROC. It has to be continuous on that closed interval. You can't lift your pencil. And there's one other stipulation. And they do this on purpose. They open the interval from a to b. It has to be differentiable. That means it has to be a smooth curve. Can't have any of those cusps. No cusps.